In this video today, I'm going to be walking through how I would answer this question on the binomial expansion, which I took from an A-level exam. It might be wise, if you want to work through this yourself now, to pause the video and then unpause it when you've finished, and then you can see my work solutions and then you can mark it with me. I got this question from an Edexcel International A-level paper, which was paper P4 that was sat in October 23, and it was the first question on that. Okay, I'm going to start walking through this question now. The binomial expansion is different in year 12 than it is in year 13, and I think it's worth having a look at the kind of form that this binomial expansion takes by changing it from being in fraction into index form. So I think that's the first thing that I would actually do. Now I can see that our fraction here, which is 8 over 2 minus 5x squared, we can't expand it yet. We have to write it in index form, and if we do that, we get 8 lots of 2 subtract 5x to the power of negative 2. Now I'm noticing that that power is a negative value, which is going to remind me that I can't use the binomial expansion from year 12 because that only dealt with positive powers, and that I have to go to my year 13 knowledge in order to expand a bracket that has either a fractional or negative power. So I think what I'll do under here is I'm going to actually write the formula from the formula book. So I'm just going to write, so from the formula book, we need one that deals with fractional or negative powers. Just to have a look at what expansion we actually need. Now there is an expansion that's written as 1 add x to the n, and that suits us really nicely. And we're going to write 1 add nx, add n lots of n minus 1 over 2 factorial, multiplied by x squared, add n lots of n minus 1, n minus 2 over 3 factorial, lots of x cubed. And that works for fractional or negative powers. So I think that's definitely the formula that I'm going to be using here. I'm going to get myself a nice colour here that I'm happy using. Pop this in a bit of a bubble. Just going to highlight that. We don't need to learn this formula, but the more we end up using it for exam questions, the more the pattern we kind of remember. That's certainly the case for me. Now I notice that I've got to have the bracket in the form 1 plus x. Really, really important there. And as I look in our bracket, I can see that that definitely isn't in the form 1 add x. And I do need to change that form before I can even hope to get started. Now I'm going to get the right colour pen to start with. I'm going to write it in a slightly different way. I'm going to write it as 8 lots of, and I'm going to factor out that 2 from inside that bracket there. So I've got 2 lots of 1 minus 5x over 2. And because that whole thing was to the power of negative 2, I mustn't forget that I'm going to need to raise 2 to the power of negative 2 and what's in that bracket to the power of negative 2 as well. And if I do that, I'm going to get 8 lots of, and I'm going to get 2 to the negative 2, which is a quarter, and the bracket is 1 minus 5x over 2 to the power of negative 2, and 8 times a quarter is 2, and then I've got the bracket 1 minus 5x over 2 to the power of negative 2. Now, I'm ready to get on to my expansion, because although it doesn't say 1 plus x, I still have 1, and then I have a term with an x in. So that's fine. As long as I deal with it correctly, that's absolutely fine. Now, I'm not going to skip anything. Oh, by the way, that would be worth a mark in itself. If you stated that that's how you were going to deal with it, that would be worth a mark. Now, I'm going to not skip any steps at all, and I'm going to keep that 2 in front of my bracket. I'll have it as a curved bracket because that's going to be the continuity that you'll be able to see. So I'm just writing it out again here, and I'm going to say, you know, hey, I'm going to substitute everything into that expansion formula, not forgetting that I've got to have a 2 outside. That's really important because sometimes students do forget that. Now it's crucial that I substitute everything into the formula in the right way in order to get a method mark, but also if I'm successful in doing that, I will also get an answer mark. So I'm going to be very careful about this. 1 add n. My x term is negative 5x over 2. Add n minus 1 over 2 factorial. My x term is negative 5x over 2 squared. Add n minus 1, n minus 2 over 3 factorial. My x term is being cubed. I know there's more if I chose to go on, but the question is only asking me for the first 4 terms, which is equal to 2 lots of. Keep that there. So I'm just going to tidy this up a bit and do any simplifying that's nice and easy for me to do so. Oh, by the way, that would be worth a method mark and an answer mark in itself because you have an accurate form of your expansion. I want to get the simplest, it says writing each term in its simplest form, so I'm going to have to carry on. So I'm going to get 1 add 10x over 2. And then I'm going to have add negative 2 times negative 3 is 6. 2 factorial is 2. And I'm not going to simplify all of that yet. I'm just doing it step by step. 25x squared over 4. Add 2 times 3 is 6 times 4 is 24. So that's going to be negative 24 over 3 factorial is 6. And in brackets, I'm going to have negative 125x cubed over 8. Noticing that my calculator hasn't come out yet, I don't need to resort to my calculator yet. I like to do as much as I can without my calculator. You might work differently, but that's how I prefer to work. 1 add 5x. I've got 3 lots there of 25x squared over 4. I've got negative 24 over 6. But I've also got the negative value there. So I'm just going to take it slowly because I don't want to make a mistake. I've got negative 4 lots of negative 125 x cubed over 8. The very last thing I want to do is make a mistake, because every mark you lose takes you further and further away from that grade boundary that you really firmly need to be at. So I've got 2 add 10x add well, I've got 6 times 20, well, I have 6 times 25x squared over 4. I'm just going to keep it like that for the moment, just to get my thoughts clear. I'm going to multiply the 2 by the negative 4, which is a negative 8, and negative 125x cubed over 8. And then my last step is I'm just going to simplify everything. 2 add 10x. I've got 6 over 4, which is the same as 3 over 2. And 3 times 25 is 75x squared over 2. Now the negative 8 and the 8 cancel to give 1, and I know that I'm dealing with a positive coefficient there, so add 125x cubed. I know it goes on. I'm certain that that's my answer, unless I've made a mistake. I don't think I have, and therefore I would get an answer mark for simplifying each coefficient and each term. Part B says find the range of values of x for which this expansion is valid. And if I think about the actual expansion that I did, we have to consider the bracket just inside the bracket. So I'm just going to consider 1 minus 5x over 2. Okay, so to the power of minus 2, of course, but it's really inside here that I want to consider. Now, if 5x over 2 was equal to 1, then 1 subtract 1 would be 0. So that wouldn't be an expansion at all. I think, therefore, that implies that 5x over 2 is going to have to be smaller than 1. But because we could also expand, but if we had something less than 0 in that bracket, like for example negative something, we could potentially expand it. It's just we can't expand something that's equal to 0. So I think the modulus of 5x over 2 is going to have to be less than 1. And if we kind of, carry on, 5x, the modulus of 5x has to be less than 2, and then the modulus of x has to be less than 2/5, which is the answer. And that's fine. That's an answer mark as well. If you wanted to write x has to be smaller than 2/5 or greater than -2/5, that's also fine as well. I hope that made sense. I'm just going to zoom out so you can see the whole thing. I hope that made sense. Please continue to watch my videos because I will be doing a walkthrough of exam questions on lots of different topic areas. Thanks ever so much for listening.